Okay, welcome back. We're in Chapter 18, Quiz A. Let's just take a minute and look at the prompt. According to Gallup, about 33% of Americans polled said they frequently experience stress in their daily lives. Suppose you're in a class of 45 students. What is the probability that no more than 12 students in the class will say that they frequently experience stress in their daily lives? Make sure to identify the sampling distribution you use and check all the necessary conditions. Okay, let's start by checking the conditions. First, we're going to check for normality. We check for normality by making sure that there are at least 10 successes and 10 failures. That means n times p has to be greater than 10, and n times 1 minus p also has to be greater than 10. Well, our p, our true proportion in the population, is 33%. That's what Gallup tells us. So let's check for normality. N, number of people in the class, 45, times 0.33, which is the probability of success. You know, if you call being stressed successful, must be greater than 10. And in fact, 45 times 0.33 is 14.85, and that is in fact greater than 10. You also must have at least 10 failures. 45 times 0.67 must be greater than 10, and 30.15 is greater than 10. So we have in fact checked for normality. We now need to check for independence. In order to ensure independence, the population must be 10 times larger than the sample that is being used. This is called the 10% condition. Well, our sample is 45 students. I'm pretty certain that is less than 10 times the population of people who experience stress. So clearly you see here the population of Americans is clearly more than 10 times 45, or 450 people. So now that all conditions are met, we're going to answer this question. Okay? So since all the conditions have been met, the central limit theorem tells us the sampling distribution of this proportion follows the normal model. So let's take a minute and define our variables. We know P is the true proportion in the population, which is the 0.33. We know P hat is the sample proportion, and for us this is going to be 12 over 45. That's going to be our P hat. Okay. And our 1 minus P is going to be 0.67. So we know this follows a normal model. We also know that the parameters of this normal model will be P, comma, the standard deviation of P hat. Well, we have P, it's 0.33. We need to find the standard deviation of P hat. We know that formula is the square root of P times 1 minus P divided by N. So here you go. This is the standard deviation of P hat. It's P times 1 minus P divided by N, the number in our sample population. We take the square root of that value, and we have the standard deviation of P hat is 0.07, rounded 3 places after the decimal. So the central limit theorem tells us we have a normal model with parameters P, 0.33, and standard deviation of 0.07. So take a second, let's sketch our normal model. Make sure we label its parameters. And voila, here would be our P, 0.33. One standard deviation to the right would be 0.4. Two standard deviations would be 0.47, etc., etc. One standard deviation to the left would be 0.26. Two standard deviations to the left is 0.19, etc., etc. So take a minute and label your model. Make sure you have the parameters for your model clearly labeled. And you have your z-score line. So next, we would like to find the z-score that corresponds to no more than 12 students. Well, our z-score formula is p hat minus p divided by the standard deviation of p hat. So we have all this information right over here. So we're going to plug it in, plug it in. Oh boy, that was a little overzealous of me. Here we go. So here's our z-score, 12 divided by 45 minus 0.33. You're going to find that value, divide by 0.07, and you get a z-score of approximately negative 0.905. So let's just label our z-score. So here would be 0. We know negative 1 would be right here. So negative 0.905 is just a little tweak. This is where negative 0.905 would rest. Let's see. And this would be the shaded area under our normal curve. You guys know I'm so great at shading stuff in. That would represent no more than 12 students in the class say they experience stress. So we're looking for this probability right here under the curve. So in order to find that probability, we're looking for the probability of x is less than or equal to 12 over 45, or that's the same as the probability of z being less than or equal to negative 0.905. So we're going to take out our graphing calculators. We're going to go to our normal CDF function, and we're going to pick a really small lower bound number like negative 99999. Our upper bound is going to be negative 0.905. Our mu is 0. Our sigma is 1. And we find the probability that z is less than or equal to negative 0.905 is approximately 0.183. Well, what does that mean in context of this problem? It means the probability is about 18.3% that no more than 12 students will say that they frequently experience stress in their daily lives.